In this video, we'll be going over edit distance. So given two strings, word1 and word2, return the minimum number of operations required to convert word1 to word2. You have the following three operations permitted on a word. So insert a character, delete a character, and replace a character. Now for first example, we have horse and ROS, and it requires three minimum operations to convert horse to ROS. So the first operation is replacing the character H with R. And the second operation is removing the R that's in the middle here to get rows. And then we can remove the E at the end to get ROS. Let's go over the thought process. We will be first implementing a recursive brute force approach. We can have two indices, I and J, to indicate our current location inside word1 and word2 respectively. Then in each of the recursive call, we'll be comparing the characters at the two indices. So we can compare the characters, we can call them C and D at the two indices. If C and D are equal, then we can move both pointers forward. If C and D are not equal, we have three choices as we see here on the three operations. The first one is inserting a character. If we insert a character into word1, that means we need to move the pointer inside word2. If we insert a character inside word1, we will need to move the pointer inside word2. So we're going to set J to J+1. Then the next one is if we delete a character inside word1, this means deleting the current character. That means we can just skip it. So we will need to move the pointer inside word1. So we're basically skipping the current character. So we'll be setting I to I+1. Then if we decide to replace a character, that means we will need to move both pointers forward. This will give us, so we're going to set I to I+1, and then we'll set J to J+1. Since we have three operations, we want to take the operations that will give us the minimum number of operations. So we will pick the choice that will give us the minimum number of operations. Now let's go over the code, the pseudocode. So we're going to implement the recursive approach. Now what parameters do we need? We'll first need I, our current index, inside word1, and J, our current index, inside word2, and word1 is the input word, and word2 is the input word. And then what's the base case? We have up to three base cases. So the first base case is if both I and J are out of bound. This means there are no more operations left, so we can return 0. If only I is out of bound, this means if I is out of bound and we still need characters for word2, this means we need to insert characters. And the number of characters we need to insert is return word.length, word2.length minus J. This means this is the number of characters we need to insert. Then if J is out of bound, this means our current pointer inside I is not out of bound yet. This means the remaining operations will be deletion. So we're going to return word1.length minus I. Then in each of the recursive call, if the characters at the two pointers are equal, then we can return the recursive results of moving both pointers forward. This means we do not need to perform any operations. We can just move both of them forward because the characters are the same. Else, there are three operations we can make. Is the insert, delete, and replace, and we want to pick the choice that would give us the minimum number of operations. So let's first do insert. So recursively find the number of operations. Let's call it OPS1 if we perform an insert. And if we perform an insert, we got to move j to j+1. So let's set j to j+1. Then we can say recursively find the number of operations. We can call OPS2 if we decide to delete a character. So we move I forward. Perform a deletion. We're going to say I to I+1. Then recursively find the number of operations, OPS3, if we perform a replace. Just means we need to move both pointers forward. Then we want to return the minimum value between the three operations incremented by 1, because the increment by 1 is to account for the current operation. Now let's go over the time and space complexity. So time complexity is O of 3 to the n plus n, where mn are the length of the two input strings. This is because in each of the recursive call, we have up to 3 choices and a depth of n plus n. Space complexity is equal to O of n plus n. This is the recursive call stack memory. Now let's go over the code using our pseudocode. So we're going to return the minimum edit distance. First, we're going to implement our recursive approach. Our two pointers, I and j, word 1, word 2. Now, if both of the pointers are out of bound, this means no more operations left. Then we can return 0. Then if I is equal to word 1 down length, this means I is out of bound. So we return, as we see here, word 2 down length minus j. If I is out of bound, that means the only operations left is insertion. And then if j is out of bound, then the only operations left is deletion. So it's word 1 down length minus I. Now we're going to check the characters at the two pointers. If the current characters are the same, then we can return the recursive results of moving both pointers forward. Else, we want to find the minimum number of operations from our 3 choices here. So we're going to say return math.min. So in this one, we can move our j forward first. So we can say j forward, word 2, and then we have another math.min because we need 3 operations. The next one, we can move I forward. And the next one, we move both pointers forward. Do not forget to increment by 1 because we need to account for the current operation. Okay, we get our TLE error. So let's write this down. So this approach is not efficient enough due to overlapping recursive calls. We can avoid overlapping recursive calls using memorization. And we will be going over the memorization approach in our next video. Let me know if you have any questions in the comment section below.